Hi, everybody. Welcome back. We've been working on polynomials, and I've had several requests to do more polynomial problems that are a little bit more advanced, and especially the ones focusing on perimeter and area, and some of these what we call puzzle problems, where they give you part of the information that you need to solve the problem, but you need to do a little bit of math to figure out the missing pieces before you can get your final answer. So let's get started, and we'll start with this figure that they give us here, A, B, C, D, E, F, kind of a compilation of rectangles here. And we're asked to find several pieces of information. Now, first suggestion is whenever you have one of these puzzle problems, definitely read ahead and see what they're asking you to find. Because in a problem like this, if the question is only asking me to find one small piece of the figure, then I don't want to spend a ton of time trying to solve all the missing parts when I only need one little piece. So in this case, though, they're asking us to pretty much figure out all the missing pieces of this puzzle and then go on to find the perimeter and the area. So let's get started. All right, so first things first, we want to make sure we pay attention to all of the markings on here. So these little tick marks here, those tick marks are really important because it's telling me that those two line segments, FE and DC, these are congruent. And notice up here in my directions, it says the figure is not drawn to scale. So I don't want to just count on, I can't just count the little boxes and say, okay, it must be the same length as that. That's not what it's trying to do here. And as a matter of fact, as it's drawn, DC is clearly a little bit shorter than FE. But because it has this one tick mark in both of those places, I know that these line segments must be the same length. So I'm going to go ahead and mark up my figure, and I strongly suggest that you write right on the diagram if you can, or sketch it out on your paper if everything's online, because it's so much easier to work with if you're marking up your actual diagram. So we know that FE and DC are congruent, and then we also know, since these have two tick marks, we know that AB and BC are the same length as well. So that's helpful, except for that neither of those line segments has any type of expression to show that their length yet. So we need to do a little bit of detective work here. So if we can figure out the missing pieces for AB, then we'll know the answer for BC. So if we think about AB, if we extend this here, I know the length of FE is 3x squared plus 6. That means this little part down here is also 3x squared plus 6. And so that tells me this whole length up here is the same as the entire length at the base. So I just need to add 3x squared plus 6 and 3x squared plus 6. And so I'm going to get 6x squared plus 12. And then since we know AB is the same length as BC, I can go ahead and write that in as well. And then we can write it over here as we go. So AB without the line segment, the bar over it, means it's looking for the length of the segment AB. And here we're just looking for the expression. All right, so AB is 6x squared plus 12. BC is also 6x squared plus 12. DC we found already. And then we need DE. Well, DE, that's a little bit more work, all right? So DE is right here. Similarly to how we found AB, we know that this side over here is equal to 6x squared plus 12, and DE is going to be the part that's remaining after we subtract out, oops, if we can take BC and subtract AF, so let's write that here. DE would be equal to BC minus AF. So now we can do a little math and figure out what that would be. So we have BC is 6x squared plus 12, and then subtract AF. And remember, we want to put that whole value, that whole expression in parentheses. One of the big mistakes is people forget to distribute that negative. We talked about that in the last video. But so we'll subtract out the value of AF to get DE. So we'll have 6x squared minus 2x squared, we get 4x squared. And then 12 minus 4x, wait a second, those don't go together, do they? So we need to just make it minus 4x and then plus 12, and that would be our answer for DE. Right there. Okay, so don't get confused about combining your like terms. Remember, it has to be like terms, so I can't combine anything with the 12 and the 4x. Okay, so now we have all the missing pieces for our puzzle here. And then, so number 4, we're asked to write an expression to represent the perimeter of the entire figure, and then simplify our work. So what simplify our work, that just means we need to combine all the like terms and put them all together. So perimeter, if I start at the top here with AB and work my way around, so I have 6x squared plus 12 plus 6x squared plus 12 plus, and I have 3x squared plus 6 and 3x squared plus 6, that's another 6x squared plus 12 plus, now don't forget the DE part right there. We have to do 4x squared minus 4x plus 12, and then plus AF, so 2x squared plus 4x. And now we need to go in and combine our like terms. Remember, we want to start with the highest exponents first. So we have a 6x squared, another one, 4x squared, and a 2x squared. So 6 plus 6 plus 6, that's 18, plus 4, that gives me 22, plus 2. So that's 24x squared. And then we'll go to our x's, since that's the next level of exponent. So I have a minus 4x and a plus 4x. So look at that. Isn't that nice? They cancel out. And then I'll go on and do my constants here. So 12, 12, 12, and 12. So that's 48. So did I get them all? 1, 2, 3, 4. Yep. And so the perimeter, the expression for the perimeter is that it's just 24x squared plus 48. And if they gave us a unit of measure like feet or inches or something like that, you should put that in your answer as well. Okay, so now we need to find the area of the figure. That's a little bit tougher. And so I copied this figure a little bit down here so we could write on it again, so it's a little bit easier to do. So there are a couple different ways we could do this, but you kind of just want to be creative and usually the way that I do this is I break it into pieces, and you can either break it into pieces where you're adding two pieces back together, or break it into pieces where you're subtracting something. So, for example, you could find this whole rectangle, which is actually a square, if you think about it, do this whole part, which would be length times width. So you could just do AB times BC. And then we would have to subtract out this little rectangle down here, FED, and let's call it X, that little point down there. That would be one way to do this. I think there's actually an easier way, given how complicated the expression for DE is down here. I think it's actually going to turn out to be easier if we break this into two pieces and we find two different rectangles and add them together. So if we can find this first piece, and then we'll add it to this piece, we're going to get the area that we want, of the figure that we want. So let's first find the red part. So in order to find this red square, let's see, we'll draw it like this part. That's going to be the 3x squared plus 6. And then I'm going to multiply that by this part, because the area of this little red shaded rectangle is just length times width. So that's the length and the width of that figure. So when I multiply this together, I want to be careful with these exponents here. I'm going to FOIL this together. So I'm getting 3x squared times 2x squared. That gives me 6x to the fourth, because I add my exponents. And then 3 times 4 is 12. So I get plus 12x cubed. And then I'm going to get plus 12x squared plus 24x. So that is the area of just that red shaded square. And now I want to find the area of the blue part here. So I know that one side of the blue figure is this 6x squared plus 12. And the other side, since DC is congruent to FE, I know that the base of this rectangle is 3x squared plus 6. So when I find the area of this, I'm going to, again, FOIL these together. Let's see, get that. So now the trick comes that I have to add these together to get the total area. So when I do that, I'm going to add this whole component and this whole expression here. So let's just write them again down here. So I have 6x to the fourth plus 12x cubed plus 12x squared plus 24x. And I can, in a problem like this, I think it might be easier just to write, oops, I don't have any x cubed in my second problem. Is that right? That's right. Okay. So, so I'm going to leave a blank here. And then I have 36 and 36, that's 72x squared plus, and I don't have an x, and I have a 72. So I'm going to line all this up and add them up. So let's see, I have 24x to the fourth plus 12x cubed plus 84x squared plus 24x plus 72. And that would be the area of the whole kit and caboodle figure. Whew. And remember, if you were given units, like inches or something like that, it would be square inches would be your units of measurement for the area, and it would just be regular inches, not squared, for the perimeter, because that would just be linear and not area. Okay, here's another one. This is a little bit easier and more common, so you definitely need to know how to do this one. So example 2, find the area of the shaded region, the yellow shaded region. So it's kind of like finding the area of a donut. So we'll get to those at some point too. Anyway, the area of the big rectangle is length times width. So 5x plus 8 times 6x plus 2. Okay, so I want to combine these terms in the middle here. So I'm going to end up with 30x squared plus 58x plus 16, 5x squared plus 30x over here, and I want to subtract that whole amount. So one way to do that is to write that over here and work vertically. So I'm going to write that. I'm going to say minus 5x squared and then minus 30x, and then I can just line the like terms up and work from there. So I get 25x squared, and then 58 minus 30, I get 28x plus 16. And so that's the area of the shaded region. Area of the shaded region. There we go. And that's it. That's not too bad. Okay, and here's the last example, but this comes up a bunch. So example 3, the length of a rectangle is 5 less than 3 times the width. Find the perimeter of the rectangle, or certain problems might ask for the area. So these words are confusing sometimes, but remember, less means I'm subtracting, and if it said more, I would be adding, but this is less. So I'm subtracting 5 from 3 times the width. So the first thing we want to do is just identify what is the width. So let's call the width x. And then the length is 3 times the width minus 5. So find the perimeter of the rectangle. So on these problems, it's always good to draw a little picture. All right, so we get 3x minus 5, and the width is x. So for perimeter, I need to add up all 4 sides. So I'm going to say 3x minus 5 plus x. And then we know that this is also 3x minus 5, and this is also x. So I have 3x, 3x, a 1x, and a 1x. So 6 and 8. And then I have minus 5 minus 5. So I get minus 10. So the perimeter is 8x minus 10. Another way you could do this also is if I take the two sides, 3x minus 5 plus x, I can multiply all of that times 2 because there are two sides that are the same, right? And I'm going to get the same exact answer. Okay, so we just finished 3 pretty complicated problems on perimeter and area with polynomials, and so hopefully that gives you a pretty good overview and some more practice of what you might see on your upcoming quiz or test. Hope that helps, and just remember you can do it. Just keep practicing, and we'll see you next time.